Welcome to our journey through the cosmos, where we unravel the wonders and mysteries of the universe. Today we're diving into one of the most enigmatic topics in astrophysics, dark matter. Let's embark on an exploration of the unseen, the invisible world that shapes our universe. Dark matter, a term that often punctuates discussions about the cosmos, is a kind of matter that, unlike the stars, planets, and even us, does not emit, absorb, or reflect light. It's completely invisible to our eyes and even our most sophisticated instruments. Yet in this grand cosmic stage, dark matter is not a mere supporting actor. It plays a leading role, accounting for approximately 27% of the universe's total mass-energy composition. A staggering figure when you consider that the stuff we can see, the ordinary matter, constitutes only about 5%. So imagine this. For every star or galaxy that lights up the night sky, there's an unseen counterpart, a ghostly presence that does not interact with light, but nonetheless exerts a profound influence on the cosmos. It's like a secret symphony, a cosmic ballet, being performed on a stage that we cannot see, but whose effects we can feel. Now you might ask, if it's invisible, how do we even know it's there? Well, it all started with an observation that didn't quite add up. A cosmic conundrum that led to the proposition of this unseen, yet massive, entity. It's a tale that begins with the stars, spirals into the galaxies, and takes us into the deepest corners of the cosmos. So, what led to the discovery of this invisible yet massive part of our universe? The answer to that question takes us back in time, to the early 20th century, and it's a story that we'll delve into in our next segment. Stay tuned as we journey into the darkness and unravel the cosmic mystery that is dark matter. The concept of dark matter first emerged in the 1930s when astronomer Fritz Zwicky noticed something peculiar about the Coma cluster of galaxies. You see, Zwicky was a Swiss astronomer and he was studying the Coma cluster, a large group of galaxies that lies roughly 320 million light-years away from Earth. Now, Zwicky was trying to calculate the total mass of this cluster. He did this by observing the galaxy's velocities and using a bit of gravitational theory. But when he crunched the numbers, something didn't quite add up. The galaxies in the cluster were moving way too fast, given the amount of visible mass. According to the laws of gravity, they should have been moving much slower, or the cluster should have been torn apart by now. But it wasn't. It was as if there was some extra gravitational glue holding it all together. This led Zwicky to propose an audacious idea. He suggested that there must be some form of unseen matter in the cluster, matter that was invisible to our telescopes, but could exert a gravitational pull. He called this unseen matter dunkle materiae, or dark matter. Now, Zwicky's ideas were mostly ignored at the time. After all, this was an era when the existence of other galaxies beyond the Milky Way was still a hotly debated topic. The concept of invisible matter seemed far-fetched to many. But as technology advanced and we got better at looking into the cosmos, more and more evidence started to pile up supporting Zwicky's theory. We observed that galaxies were spinning too fast, that galaxy clusters were too heavy, and that light from distant galaxies was bending too much. All these observations pointed to the same conclusion. There's a lot more stuff out there than we can see. So we know dark matter exists due to these gravitational anomalies. But what else can it do, you might ask? Well, let's dive deeper and find out in the next segment. Dark matter doesn't interact with electromagnetic forces, making it invisible. However, it does exert gravitational forces. Now, this might sound perplexing. How does something we cannot see have such a palpable influence? Well, the answer lies in the very fabric of our universe. You see, gravity is a fundamental force that acts between all masses, even those that are invisible to us. And it's this force that dark matter uses to make its presence known. In our cosmic neighborhood, the gravitational effects of dark matter are most noticeably seen in the way galaxies rotate. In a world without dark matter, the stars at the edge of a galaxy should move slower than those near the center, much like the outer and inner lanes of a running track. But that's not what we observe. Instead, the stars in the outer regions of galaxies are found to be moving just as fast as those near the center. This perplexing phenomenon can only be explained if there is more mass in the galaxy than what we can see. And that's where dark matter comes in. Imagine the galaxy as a giant whirlpool with visible matter, the stars, planets and galaxies, as the water that we can see swirling around. But underneath the water, there's a larger, invisible structure causing the whirl. That's dark matter, a hidden mass that exerts a gravitational pull, influencing how galaxies rotate and holding them together. Yet despite its apparent influence, the exact nature of dark matter continues to elude us. It's like trying to describe the shape of a gust of wind. We can't see it directly, but we can observe its effects, feel its power. And just as wind shapes the sand dunes, dark matter molds the universe, silently sculpting the galaxies and guiding the cosmic dance of stars. And while we may not yet fully understand what dark matter is, its gravitational effects provide undeniable evidence that there's more to our universe than meets the eye. Scientists have proposed various particles that could make up dark matter, like WIMPs or axions. WIMPs, or weakly interacting massive particles, are hypothetical particles that are thought to be both heavy and slow-moving. They only interact with gravity and the weak nuclear force, making them challenging to detect. On the other hand, axions are a different type of hypothetical particle proposed as a solution to a problem in quantum physics. If they exist, they are expected to be extremely light and abundant, making up a large portion of the dark matter in the universe. There are other candidates too, such as neutrinos, which are tiny particles that rarely interact with matter. However, neutrinos known today are too light to account for all of the dark matter. Identifying these elusive particles requires some of the most sensitive detectors in the world. Scientists use a variety of techniques to try and catch a glimpse of dark matter. For instance, there's the Large Hadron Collider, the world's largest and most powerful particle accelerator, which attempts to generate dark matter particles by smashing protons together at near light speeds. There are also underground laboratories, like the Xenon 1T experiment in Italy, which uses a giant vat of liquid xenon to try to detect the tiny flashes of light that would be produced if a WIMP happened to pass through and collide with a xenon atom. But despite these sophisticated experiments, we have yet to find conclusive evidence of dark matter. It's like trying to find a ghost in a vast cosmic haunted house. But even though we can't see it, we can see its effects, and we know it's there. Dark matter continues to elude us, but the search goes on. Scientists are persistently refining their experiments, developing new theories and using more advanced technology in the hope of finally revealing the nature of this shadowy substance. Despite our best efforts, dark matter remains a mystery. But we do know it plays a vital role in the universe. Dark matter is crucial in the cosmic web, the large-scale structure of the universe. This cosmic web is a grand tapestry of galaxies strung across the universe, a testament to the intricate architecture of cosmic structures. Dark matter, invisible yet influential, serves as the skeleton of this web. By exerting gravitational forces, dark matter guides the formation of galaxies and galaxy clusters. Think of it like a cosmic sculptor, shaping the universe without ever being seen. It's like the hidden framework supporting a magnificent cathedral, unseen but absolutely vital. Galaxies, those glittering celestial cities we see in the night sky, cluster along the strands of this cosmic web. These strands trace the distribution of dark matter, knitting together the universe in a complex pattern of clusters and voids. Dark matter, therefore, is a key player in the universe's structure and evolution. Despite its elusive nature, it has a profound influence on the universe, shaping the cosmic landscape into the stunning panorama we see today. So dark matter remains one of the greatest mysteries in modern astrophysics. This elusive force, unseen yet omnipresent, continues to baffle and intrigue us, shaping the universe in ways we're still striving to understand. From its initial discovery in the 30s, when Fritz Zwicky noticed galaxies behaving oddly, to its gravitational effects that defy our understanding of physics, dark matter has consistently challenged our perceptions of the cosmos. Despite our most advanced detectors and experiments, the particle nature of dark matter remains a riddle waiting to be solved. And yet, its role in the universe is undeniably crucial. acting as the unseen scaffold in the cosmic web, guiding the formation of galaxies and galaxy clusters. As we reach the end of our journey through the shadowy realms of dark matter, we're reminded of how much of the universe is still shrouded in mystery. But every mystery is an opportunity for discovery, and we're thrilled to have you with us on this voyage of cosmic exploration. Let us know in the comments what you think dark matter could be, and what other cosmic mysteries you'd like us to explore. If you've enjoyed this expedition into the unknown and are eager for more adventures among the stars, please consider hitting that like and subscribe button. Your support helps us unravel more of the universe's secrets.